I reckon I could write a book where every chapter starts. Once I was working in a school and this happened. And there'd be some hair curling stories in there, that's for sure. Once upon a time, I was working in a school and the science laboratories were designed by someone with no science experience. True story. And so the bench tops that the students and teachers were supposed to work on were made of stainless steel, conducting. So when it came to doing experiments that involved monitoring of temperature or humidity or light or whatever, and we were using UNOs, if the UNO was powered and put down on that bench, then it fried it. And then, they threw a lot of these things away, which is very sad. So I didn't let them throw them out. Of course, I kept them. And maybe we might try and resurrect one or two of them. So these two here, if you power on, then you get the classic fast blinking lights there that would indicate that there's something wrong with possibly the chip. I mean, maybe other things have blown out, but a short circuit would definitely blow out that chip. If we have a look at the other one, do we get the similar thing? That's a steady light on, so hard to say what the problem is. Neither of them will talk to a computer, and so programming them is obviously going to be problematic. So what I do have is I got a heap of 168 Atmega 168 and Atmega 88 chips. So I was thinking maybe it's time to do some surgery. I'm going to pull these guys off using a hot air gun, and then I'm going to replace them and see if I can't get the computer to talk to them. That's the plan.
So a liberal application of flux and an enthusiastic application of a hot air gun, and these chips were pretty easy to replace in the end.
Maybe shouldn't have used the hot air gun with this degree of enthusiasm. So I've melted some stuff here and melted some stuff here. But, female headers are easy enough to replace. I'm really keen to plug these guys in now and see if I can resurrect them. So let's go to the computer.
So here's the USB ASP programmer plugged into the computer and going down to the ICSP headers on a remastered Uno with an Atmega 88 running a Blinky.
Because of my error, both of these remastered Unos ended up with the Atmega 88 in them. I'm not sure how that happened. I was going to put a 168 in one and an 88 in the other, but they've both got the 88 and they're both working. So the only way I was able to program them though was using the USB ASP. I wasn't able to actually access the chips at all via the USB, via the CH340 chips. One of them, the USB was recognised but still not able to program. The other one just didn't come up as a USB port at all. So there might be a few more components on here, including the CH340, which could be fried. But proof of concept, I guess, that they are able to be reprogrammed. So here they're just running a quick blinky. They've just been fed 5 volts in parallel from the PSU, and everything's working fine. So good result. The only other thing that I'll probably try and do, because I'm a bit mad, I still don't want to throw these out without testing them. I do have a high voltage fuse setter. So I'm just going to run this past that, and I'm pretty sure they're dead, but that's just going to be the final thing before I turf these. But got a couple of working Unos out of them, as long as they're programmed by the USB ASP, and as long as you don't mind that they've got, well, in this case, 8K instead of 32K of memory. But yeah, that's the circuit working for this week. Not a bad recovery.